All right. Once again, you're welcome to this our online class, and of course, this is statistic class, and it's actually meant for students that are in the statistic class. That is, students that are in statistic class. In our last video, we have been able to talk about the correlation, where we discuss about the Spearman rank. We also discuss about the Pearson correlation. So today is the continuation of that of last video, which is also on the statistics. So this class, like I said, like I promised in the last video, that will majorly focus on the inferential statistic. And I said this class will be for, is going to serve as a step-by-step through the concept of hypothesis testing, especially in inferential statistics. So we are going to use a clear and relatable example, let's say from the education perspective, since this is talking about statistics in education. So we are also going to explain what we mean by hypothesis testing. Why is it important in educational research and evaluation? And how data from a sample can be used to make a decision about a particular population. So we are going to look at the two common statistical tools, which is the t-test and then the chi-square. So also tell you when it is appropriate to make use of these tools, then also how we structure a null and alternative hypothesis. I will also tell you how you can interpret your result correctly. Then we also, go into the practical class. We look at the classroom-friendly example we use in the t-test and then that of chi-square, including maybe you want to compare students' means achievement score with their examining relationship between the categorical variables, such as maybe we are looking at the gender, the subject, we are looking at the educational qualification, or the student habits, or the learning outcome of the student. So that is what the video is going to focus on. So without wasting much of our time, I will just take you through some of those things you need to know before we go into the inferential statistics class. Like I said, we have really dealt with the first types of statistics, which is the descriptive statistics. So this time around, we want to go deep into what inferential statistics, especially for t-test and that of chi-square, is all about. So we are going to look at the two. We'll pick them one after the other. So even before we go into that, like I said, both the t-test and then the chi-square is actually talking about hypothesis testing. So in educational research, we often interest in making some decision, and we would like to draw conclusion about a large group of people. Maybe you are performing and you are carrying out a research on student or teacher or school. You want to make a kind of a decision or drawing a conclusion about that set of people. So it simply usually be impossible when you study everyone in the population. For instance, now maybe you want to look at the learners outcome in mathematics of all students in Ogun State. It's just going to be too large. So what you just have to do at that moment is for you to collect data from a sample. You are going to collect the data from a sample, or you use a statistical method to make inferences about the population. And that is where we say in a selected, that's where you started hearing in selected, that means your target population. You are going to look at your target population out of the population. For instance, now, if I said I want to carry out a research on the student learning outcome in mathematics based on their gender in the whole of Ogun State, it will be too big for me. So I have to have some target people. Maybe I talk about the Ogun East Senatorial District. Basically, in each of the states in Federal Republic of Nigeria, we normally have 3 senatorial districts. So Ogun State case is also the same. We have 3 senatorial districts. We have Ogun East, we have Ogun West, and we have Ogun Central. In the Ogun East is basically comprised of 9 local governments. So if you are now saying you are looking at the learners outcome in Ogun East, of course, your title will still carry out the research among all secondary school students in Ogun State, but your target population are the students in Ogun East. So hypothesis testing is a core concept in inferential statistics, and it's going to provide a scientific and objective way of determining whether the result obtained from a sample are strong enough to support or to reject a claim about a population. That's what hypothesis testing does. So in a simple term, we can say hypothesis testing helps us to answer questions. So is the result we observe real, or we did it just happen by what? By chance. So in that way, what is hypothesis testing? Hypothesis testing is a statistical procedure used to determine whether a claim or an assumption about a population is supported by sample data. So in education, hypothesis testing help researcher or evaluator to compare. Maybe you want to compare teaching method. Somebody might have used a play-away method. Somebody might have used inquiry-based learning method. Somebody might have used what we call psychocultural method, or you have used culturally relevant pedagogy with your student. And you want to test the learning outcome of that. You can also use it is also help a researcher in evaluating the learning outcome. Like I said earlier, it can also help you to examine the relationship among variables or make evidence-based decision in policy and practices. So what are the basic concepts in hypothesis testing? You see that when I started talking about, I always mention population. So that means population is very important in hypothesis testing. Then your sample as well is important. So when we now look at it in the areas of hypothesis testing, what is population? Population refers to the entire group of interest, such as all students in Ogun State, or we say all students in a university. Maybe let's take Federal University of Education, for instance. Now we talk about you are looking at all students in Federal University of Education. You don't need to be very too big for you to sample all the students in Federal University of Education. So, and that is where the sample comes in. We can now talk about that a sample is a smaller group selected from the population for the study. A sample is a what? Is a group selected from the population for the study. So when you have a population, all students in Federal University of Education, when you now select some smaller group from there now, that one is your what? Is your sample. So decisions about a population are made based on evidence from the sample. So once I draw a sample, I can generalize that, the student habit, what is it called? The study habit of students in Federal University of Education determine their class of degree. I can just pick, we have about 7 colleges. Presently, we have 7 colleges. Maybe I can pick like 50-50 students from each of the colleges. If I pick 50-50 in 6 places, of course, that is 300. So at the end of the day, I'm using 300 as my sample. And of course, the students of Federal University of Education, they are more than 300. But based on the sample that I drawn there, I can use it to make a conclusion. So those are the basic concepts in hypothesis testing: the population, the sample. Now let's look at, on the other hand, we'll talk about the research variables. You know that most time when we talk about this, we talk about research variables and the like. So that's where we talk about independent variable and dependent variable. Many people did not even know the difference between independent variable and the dependent variable, the IV and DV. So the dependent variable is a variable manipulated or used for grouping. Maybe I should let you know that very well, that a variable manipulated or used for grouping, that is always the independent variable. For instance, now if I talk about maybe I talk about the study habits, is there any significant difference? I want to look at the influence on the gender influence on the study habit of the student. You see that gender is a variable and the study habit is also a variable. Between the two, the gender is the independent variable, while the study habit is the what? The dependent variable. So the variable manipulated or used for grouping, that is the independent variable. While the dependent variable, on the other hand, is the outcome being measured. The outcome being measured, like test score, like student achievement, student performance, all this and that, those are the dependent variable. Those are the outcome being measured. What you want to measure or your target. Why the variable that you manipulate, especially the one that you group, that one is referred to as what? The independent variable. Of course, we have talked about different types of hypotheses. I'm just trying to bring this coming together before we go into t-test and then the chi-square. So the types of hypotheses, there are two types of hypotheses. There are two types of hypotheses. We have what is called the null hypothesis and we have the alternative hypothesis. It's just like a little adjustment on the null hypothesis, then it becomes an alternative hypothesis. So a null hypothesis is the one that always comes with there is no significant difference, there is no significant effect, there is no significant relationship between variables. So anytime you are hearing there is no significant, that is a null hypothesis. So it's the hypothesis the researchers seek to test or possibly reject. That is the null hypothesis. So for instance now, if I say there is no significant difference in academic achievement of students taught with digital learning tools and those taught with traditional method. Unlike that one, if you look at it, that is a null hypothesis. Inside that hypothesis, my dependent variable is the student, is the academic achievement. Why did the digital learning tools, student taught with digital learning tools and traditional method, those are the two are the independent variable. So there is no significant difference in the academic achievement of students taught with digital learning tools and those taught with traditional method. So that is a null hypothesis. And inside that null hypothesis, we have the dependent variable, we have the independent variable. Like I said, the dependent variable there is the academic achievement. That is the academic achievement. And that is the variable, that is the outcome that you want to measure. You want to make sure the academic achievement of the student. That is what you want to measure. Is that taken now? So let's go to the alternative. The alternative, on the other hand, is just a little manipulation. Just remove the no and just say there is. And it makes it to become an alternative hypothesis. So an alternative hypothesis stated that there is a significant difference. There is a significant effect. There is a significant relationship. So it represents the researcher expectation or research claim that if this is not working, this should work. That's an alternative hypothesis. So an example is what I've just given you. There is a significant difference in academic achievement. You know, the null hypothesis is that there is no. The alternative hypothesis now will be what? There is a significant difference in academic achievement of students taught with digital learning tools and those taught with what? And those taught with traditional method. Now, let's now move on to the main work, the reason why we are here, which is the statistical tools we use in testing our hypothesis. The statistical tools used in testing hypotheses, and there are many. We have t-test, we have chi-square, we have analysis of variance. That's ANOVA. So, but for the purpose of this class, we'll just look at t-test and chi-square. So what is t-test? What is t-test? A t-test is an inferential statistical tool used to compare the means of two groups in order to determine whether the difference between them is statistically significant. It's an inferential statistical tool used to compare the means of two groups in order to determine whether the difference between them is statistically significant. So when do we use t-test? Let me even know if you can hear me clearly in the comment section. Ablasis, please, can you hear me clearly? If you are still there with me. Let me know in the comment section if you can hear me clearly. Let me know in the comment section if you can hear me. Let me just put here, can you hear me? Can you hear me? I want to hear in the comment section if you can hear me clearly. Can you hear me? Oh, thank you. Thank you, Northview. Thank you. Okay. So, like I said, so a t-test is an inferential statistical tool used to compare the means of two groups. So, and I said, when do we use it? A t-test is appropriate when you are comparing two groups only. When you are comparing two groups only. You use it when the dependent variable is numerical. When the dependent variable is what? Is numerical. And examples of a numerical data is test score or mark, student mark. So when you are comparing two groups only, I will give you an example. Or we say we use a t-test when independent variable has two categories. When independent variable has two categories. Don't forget that when we are talking about two categories, a good example is gender. Maybe you are talking about male and female, private and public. Do you get that now? Male and female, private and public. That is when the independent variable has two categories. That is when you can make use of what? Two tests. Once the independent variable is more than two categories, you cannot use t-test again. So let's see an education example where t-test is used. A t-test is used to compare male and female student achievement. You want to compare the test scores of students based on their gender, or you want to compare the test scores of the student based on the types of their school, whether public or private. Okay, you got all their scores, the scores from public, the scores from private. Now I want to see the significant difference between them. So it is used when you are using what? When it has two categories. It is also used to compare pre-test and post-test score. It is used to compare what? Pre-test and post-test score. That is when you can use t-test. Maybe you have seen the pre-test, you have conducted pre-test, and you have conducted the post-test, and you put the two together and compare them. You can only use a t-test. Let's see a good examples of t-test in education. Let's have a research scenario. Maybe a lecturer wants to determine whether the uses of digital learning tools improve student academic achievement compared to the traditional teaching. So two things there. They want to determine whether the digital learning tools improve the student academic achievement compared to the traditional teaching method. So that means in that place now, we'll be having two different things there. We're having the digital learning tools, then the traditional teaching. Those one, they are two categories, and you are comparing them with the student academic performance. And one thing I want us to know is this: when we are talking about academic performance, when you hear the word academic performance, it's quite different from academic achievement. Academic performance, you are dealing with a secondary data. That's the data when you collect a ready-made scores of the student. A good example is WAEC score. You are not the one that conduct the WAEC. You just went to let me say their SSC grade conducted by WAEC, West African Senior Examination Council. So their senior secondary school certificate is the student performance, which is a secondary data. But an academic achievement is the one you conduct yourself. Maybe you put them in a question and you give them to answer. That one is an academic achievement. So in that scenario that I just give now, the independent variable is the teaching method. And the teaching method is in two categories according to the research scenario now. That's the digital and the traditional. And the dependent variable there is the student achievement score, which is going to talk about the student achievement score. So in that wise now, I can now formulate an hypothesis for them. I can now do what? I can now formulate an hypothesis. Maybe I say the hypothesis can now be in this form. There is no significant difference in the mean achievement scores of the students taught using the digital learning tools and those taught using the traditional teaching method. And of course, the alternative hypothesis will be there is a significant difference. So that is that about the t-test. So the statistical tools is the independent sample t-test, and it has a rules. The decision rule is that if the p-value is is less than 0.05, you reject the null hypothesis and accept the alternative hypothesis. But if the p-value is greater than or equals to 0.05, you are not you are not going to reject the null hypothesis. This time around, you take the alternative. Is that taken now? So when the p-value is greater than or equals to 0.05, so do not reject the null hypothesis. So this time around, you are taking the null hypothesis. You accept the null hypothesis if the p-value is greater. But if the p-value is lesser, you reject the null hypothesis. So invariably, what I'm trying to say is that rejecting the null hypothesis indicates that the teaching, if I reject the null hypothesis now, it indicates that the teaching methods has a significant effect. So let me put it in this way now. In this scenario, based on what we have taken now, so if the p-value is less than 0.05, I'm going to reject the null hypothesis, and I will say my decision will now be there is significant difference. But if the p-value is greater or equals to 0.05, I'm going to accept the null hypothesis and reject the alternative hypothesis. So that means I will take the null hypothesis if the p-value is greater. So I hope I have explained that very well. By the time we get into the practical, we'll get a question, then we'll solve it in our next video. So let's quickly move on to the chi-square. I have just a few minutes more to move to the chi-square. The chi-square test is used to determine whether there is significant association or relationship between two categories variable. Chi-square. That one is using what? You want to know whether there is significant association or relationship. It's just like a Spearman rank and that of Pearson correlation. One is talking about the significant relationship. So likewise in this one now, when we look at when we talk about the t-test, we said is comparing the what? Is comparing the two mean. Is comparing the mean scores of the two in order to determine whether there is statistical significance. That one is testing the statistical significance. Are we together? So why this of what? Chi-square is looking at the significant association or relationship between the two categorical variable. Let's see a good example. When do we use chi-square? A chi-square test is appropriate when both variables are what? Categorical. When the both variables are what? Are categorical. I'm going to give you a good example. So data are in form of frequency count. So here, the researcher is interested in the association or the relationship, unlike the significant difference, that of t-test. So let's say in an educational situation for chi-square test, when you are looking at gender and subject preference, or you are looking at types of school and examination outcome, you are looking at types of schools maybe in form of public and private, then examination outcome in form of pass or fail, or you are looking at attendance category and performance level. Attendance category, in that place now you might have categorized the attendance whether low or high, so then the performance as well. So let me give you a scenario, maybe a research scenario, like a researcher want to find out whether the gender is associated with student subject preference, whether gender is associated with student subject preference. You know, the student subject preference in terms of the four categories we have now, maybe in the areas of science, technology, humanity, or business. So when you started carrying out a research to find out whether the gender is associated with the student subject preference, which the both of them are what? Categorical, then you are going to make use of the word, the chi-square. You are going to make use of the chi-square. So a good example of the variable is that maybe you are looking at, I'll just give you a good example, gender, which is male and female, subject preference in terms of maybe you are looking at science and humanity now. And let me show you a good statement of hypothesis for that. If they said there is a significant association, when you hear there is a significant association between gender, you know, that of t-test is talking about there is a significant difference. So that means it's talking about the significant difference. This one is talking about significant association or relationship. So there is no significant association between gender and subject preference among the students. That means you have to use chi-square. And of course, the alternative is there is. So likewise, the decision is also that it's also the same thing as that of t-test. When the p-value is lesser than 0.05, you reject the null hypothesis. When we get to the calculation, I will show you what the p-value is all about. I will show you the p-value. So that is that about the chi-square. So how do we choose the appropriate statistical tools? Of course, you use your research objective to determine the type of what is it called? The type of statistical tools to use. Let's say, for instance, now when you compare the means score of two groups, you make use of t-test because they are both numerical. Maybe let's say we are examining the relationship between two categories, which is categorical. You are making use of chi-square. Or you are looking at teaching method and achievement. That one is numerical. Both of them are numerical. So you are making use of what? T-test. But when you are looking at genders and subject choice, the two are categorical. So you are going to make use of what? Chi-square. So that is that. So in summary, we've just discussed about hypothesis testings, which help researchers to make decisions based on data. We've also looked at how we involve testing a null hypothesis against an alternative hypothesis. And we conclude that a t-test is used to compare mix of two groups, while chi-square is used to test association between two categorical variables. And we also look at the decision, and we said the decision are made using the p-value. The common statistical significant level we use in education is 0.05, and that is where we are going to stop the class for today. If you are joining us for the first time, try to make sure you subscribe to this channel so that you get notification when next we have another video that will support you in your statistics in education. And likewise, don't forget to share this video with other either undergraduate students or postgraduate students that are involving in anything that has to do with statistics in education, or that has to do with things that has to do with research in education. So ladies and gentlemen, thank you for joining us, and do try to make sure you subscribe to this channel and share this video with others. Thank you, and God bless you. So till I come your way again, I am Kayode Adewale.